let's take a look at adding and subtracting fractions. Yay, adding and subtracting fractions. You're probably pretty excited. Well, let's look at just regular fractions like you've been doing since, I don't know, elementary school, middle school. So if I was going to add 1/2 plus 3/4, we remember that we have to find a common denominator. In this case, our common denominator would be 4. So I would multiply, because of course we can only multiply by the number 1. I would multiply by 2/2 on this first fraction so I can get the denominators to match. Okay, hopefully we remember that. So that would give me 2 times 1 is 2, and then 2 times 2 is 4, plus 3/4. Now that we have common denominators, we can just add the numerators together. So 2 plus 3 is 5, and my final answer would be 5/4. That's just a reminder on finding common denominators. We're going to be doing that in, well, a bit of a more complex nature because we're, have x's and such. But that's really the concept. We're just going to find a common denominator and we're going to add them together or subtract, depending on. So looking at our first example, our denominators are 3x and 6x. So I look at those two denominators. I see they have x's in common. Great. We're going to leave that. That's good. Then the numbers, the 3 and the 6, I know that I would need the 3 to become a 6, right? So the common denominator would be 6x. In order to do that, I would have to multiply this first fraction by 2/2. That would allow me to have the same denominator. So let's see, 2 times 2 is 4, and so we've got 4 over, and then 2 times 3 is 6. Good, that's what we wanted. Okay, very nice. I've got common denominators. Now I simply add across the top. So the numerators, so 4 plus 5 is 9 over 6x. Great, I have turned two fractions into one fraction. That is my first goal. My second goal would be to simplify what I have left over if it's possible. In this case, 9 and 6 have a common factor. So you might want to just put like this. 9 is 3 times 3. And 6 is 2 times 3. We see they both have a common factor of 3. We've got this and this. So I can take a factor of 3 out, because 3 over 3 is 1. Okay, so that leaves me, let's see, it leaves me a 3 in the numerator over a 2x in the denominator. Okay, that's our very first one. We're looking at adding these little guys together. Okay, let's move to our second one. Okay, a little bit different. In the first example, I had a monomial in the denominator, just one term. In the second example, I have binomials in the denominator. I have 2 terms, and so it's a little bit more complicated. But the concept is the same, so I need to get the denominators to be the same. Now I really, really hope by now we are just so strongly, we just have such a strong knowledge that this x minus 2 and this x plus 2, they are together. We cannot pull them apart. Those x's are not the same. They are x, but I couldn't just say, oh, well, let's add 2 to this or subtract 2 from this one. I can't do that. I have to take it as a whole package, like it's a factor, right? So I really would love them to be the same, both x plus 2 or both x minus 2, but they're not. So what I'm going to have to do is I'm going to have to get the same denominator, I'm going to have to multiply this first one by x minus 2 over x minus 2. I'm going to have to multiply the second fraction by x plus 2 over x plus 2. Please notice that when I multiply, I can only multiply by the number 1. I am not allowed to just multiply by anything I want, only the number 1. X plus 2 over x plus 2, those are the same factors that would go to 1, etc. So let's do that. So I would take the 3 times the x minus 2 over x minus 2, x plus 2, minus, then I would take the 8 times the x plus 2 over x minus 2, x plus 2. And now we can see that they have the same denominators. Yay! So there's several ways that we can proceed from here. What I would like to do is just to bring that all together into one fraction. I'm not going to do any multiplying yet or distributing. I'm just going to bring it into one fraction. So I have 3 times x minus 2 minus 8 times x plus 2 all over x minus 2, x plus 2. Now, some students would be very tempted to start crossing stuff out. Just crossing, like, oh, let's cross the x minus 2's out. Oh, let's cross the x plus 2's out. So let's look at why that's not okay. This is the reason that that is not okay. There's a subtraction sign there. We are not allowed to just cross things out that are attached by addition or subtraction. That is not okay. So that's why we can't do that. No crossing out here. Instead, we need to distribute and combine like terms along the numerator. We're going to leave the denominator alone. So 3x minus 6 minus 8x minus 16, I'm just distributing across the top, over, we're just going to leave that x minus 2, x plus 2. Okay, so it looks good. So let's combine like terms now. So I've got 3x minus 8x, that would give me what, a negative 5x. And I've got negative 6 minus 16, that's what, a negative 22, all over x minus 2, x plus 2. Now, if it's possible to simplify any further, I would, but 5x and 22 don't have a greatest common factor. I can't factor anything out, so I'm pretty much done here. This is as far as we can go. Okay? All right, great. Let's look at our third example on this page. Oh goodness, look at that. I've got a trinomial on the denominator, x squared minus x minus 30. And then I've got an x minus 6. I really do not want to multiply that this fraction by that crazy x squared minus x minus 30. I want to do some investigating. Maybe there's an easier way. Maybe if this factors, it might be helpful. So let's just do our 3 terms. We're going to just test this out, see how it works. All right, what would that be? So the back sign is a negative, a subtraction, so my signs would be different. So plus and a minus. X times x is x squared. Let's see, I need to multiply to get a negative 30, and I need to add to get a negative 1. What if we did 6, put the 6 here and the 5, so that would give me negative 6x, remember we check outside inside, negative 6x plus 5x gives me a negative 1x, great, so it does factor, and looky here, I've got an x minus 6 here and an x minus 6 there. So I do have some common factors in those denominators. Now that's a big plus. What that means is all I need is an additional x plus 5 over here, over x plus 5. So I have my denominator the same. All right, so let's rewrite that. That's just a little bit of a mess. So I've got 3x squared over this factoring of x plus 5, x minus 6, minus. So then I've got this 3x plus 5, we need to treat it as one piece. You know, if you want to put parentheses around it, you can up there, but we need to treat it as one piece. We need to multiply that by x plus 5, and that's over x minus 6, x plus 5. Okay, let's step back for a moment and just see what we've done. Okay, so good. I do have a common denominator. You can see that these factors, or I call them, we've called them bubbles before, are reversed. That's okay. It doesn't matter. They don't have to be in the exact same order. They just have to be, you know, the exact same things need to exist in the denominator. The order we write them in is not a big deal. So we have a common denominator. So let's do that strategy where we bring it together into one fraction. So I've got 3x squared minus 3x plus 5, x plus 5, all over x plus 5 times x minus 6. Okay. Great, we're down to one fraction, we're making progress. Now we need to clean that numerator up. And this piece right here, they have to be FOILed, right? I mean, that's what we would have to do to that. We're going to have to FOIL it out. All right, so let's do that. So I'm going to do a subtraction. I'm going to open up a bracket. We're FOILing. So 3x times x is 3x squared. 3x times 5 is 15x. 5 times x is 5x. 5 times 5 is 25. Okay, over my x plus 5, x minus 6. Okay, so now it's a matter of combining like terms. So we've got 3x squared minus 3x squared. Oh, that goes away. That's kind of nice. So the 3x squared minus the 3x squared are gone. And then we have minus 15x. We're basically having to, hopefully, I'm sure we remember, we have to distribute this negative to all of the numbers, the terms. Now we can do that after we combine like terms, or we can do it right now. It doesn't really matter. We should get the same answer no matter which way we do it. So I've got a negative 15x minus 5x. That gives me a negative 20x and minus a 25. Okay, over x plus 5, x minus 6. Now, the only other thing we should check out is to see if it's possible to simplify this. So if I work on the numerator and I factor it, so let's just do a little scratch work over here. Let's see, I've got 20 and 25. What if I factor out a negative 5? And that would give me, what, 4x plus 5. And you can see, so this would factor to be that. I don't have a 4x5 down here, right? So it doesn't do me any good to factor like that. I mean, yes, I should check it out, but there's nothing farther I can do, so I might as well just leave it like this. You can leave it like that, or if you prefer, you can leave the numerator factored as well, and you can leave it like this. They both are acceptable answers. So you could do this one, or you can have that as your answer, whichever one you would prefer. Okay. All right, let's move to the second page. We've got a couple of problems over here to work through. Oh goodness, look at that number 4. We've got a lot going on there, don't we? Let's see, we've got an x plus 1, we've got a 2x minus 3, we've got an x. There's a lot going on there, so looks like this is going to be a little bit of work. My greatest common factor is none of these have anything in common. The x plus 1, the 2x minus 3, none of them have common factors. So the common factor is all of them. Whew. Okay, we can do that. We can do that. It's going to be a little bit challenging, but we can do that. So, all right. So this first fraction, this has the x plus 1. It's going to need an x, and it's also going to need a 2x minus 3. Okay, that's what the first fraction needs. Okay, the second fraction. All right, what does it need? Let's see. And it's kind of cramped up here. Why don't we, let's spread this out instead. So this first fraction needs, and I'll write what we're multiplying by in pink. So this first fraction needs an x times a 2x minus 3 over x times 2x minus 3. That's what it needs. And it currently has a 4x over x plus 1. That's what it currently has. Okay, plus. The second fraction needs an x and an x plus 1, x and an x plus 1, okay, and currently has a 5 and a 2x minus 3. Okay, minus. This last little fraction needs an x plus 1, 2x minus 3, x plus 1, 2x minus 3, and currently has a 4 over x. Whew, goodness gracious, there's a lot going on there. So it looked kind of small and looked deceptively simple, but this one has got a lot of work going on. So, we need to, let's do that strategy where we bring everything into one fraction. I mean, why not? Let's do that. So the numerator, I'm going to have the x times 2x minus 3 times 4x plus, we have the x times x plus 1 times 5 minus, we have the x plus 1 times 2x minus 3 times 4 all over x plus 1 times 2x minus 3 times x. Goodness. Whew. Okay. So let's kind of focus on what we're doing. We're order of operations. We're working from left to right. So in this first little piece right here, this piece right here, I've got 3 things to multiply together. And so it doesn't really matter when we're multiplying. I can multiply 2 times 3 times 4 or 4 times 3 times 2. It doesn't matter which order I do it. So let's multiply these two together first. That would make our lives a little easier. So I've got 4x squared times 2x minus 3. Okay, we got a little bit done. And let's multiply these two together. So it gives me 5x times x plus 1. Okay, all right, got that. And then I'm just picking the easiest things to multiply together. Let's multiply those things together. And that would give us 4x plus 4 times 2x minus 3. All over x plus 1, 2x minus 3 times x. Okay, well, we made one pass at it, and it's a little bit better. Let's keep going. So here we go. So I've got, let's work on the first little piece right here. So 4x squared times 2x. 4 times 2 is 8. X squared times x is x cubed. 4x squared times a negative 3 is negative 12x squared. Great, got that one finished. Now let's work on the little middle piece. 5x times x is 5x squared. 5x times 1 is 5x. Whew, making progress. Okay, so now we're going to FOIL this last piece. So 4x times 2x would be 8x squared. 4x times a negative 3 is negative 12x. 4 times 2x is 8x. and 4 times a negative 3 is a negative 12. Whew, goodness, this is, I mean, algebra, right? We love algebra, yay. We get to do all kinds of algebra stuff here. You're probably like, Dr. Wright, no, this is like not a whole lot of fun. I think it's so much fun. Okay, so here we go. Let's combine like terms. We talked before when we were combining like terms, seems like many months ago, it wasn't that long ago, where we would either highlight, let's just going to highlight all the ones with the cubes, so I just got that one. And then I've got ones with squareds. We need to work with that one and that one. Those are squareds. And then we've got ones that have just x's, and that's these. And then our poor little leftover guy is just a regular 1 digit, or just a regular number. So here we go. Let's combine. So we've got 8x cubed, nothing to add it with. Let's see, we've got a negative 12x squared plus 5. Let's see, what would that give us? A negative 7. Negative 7x squared minus 8, because I have to distribute this little negative guy, of course. We have to remember that. So let's see, negative 12x squared plus 5x squared minus 8x squared. So that gives me a negative 15x squared. Okay, got rid of the blue ones. Now let's work on the green ones. So I've got 5x minus a minus 12x. 5x minus a minus 12 would be plus, so that would be what, 17x. 17 minus 8x would be what, 9x. And then a minus 12 would be a plus 12 all over the denominator. And you're probably thinking, oh my gosh, that would be so fun if we like could keep factoring like that numerator. Maybe it's got 4 terms. Maybe we could factor by grouping. Ooh, that sounds great. I hate to disappoint you. We cannot factor that by grouping. So we just have to kind of leave the little guy just like it is. Okay. All right, let's look at our very last problem on this lesson. It's a little bit crazy looking, but we're going to use some of the same strategies. Okay. It's a little bit crazy looking because it's a complex fraction. You know, I have fractions on top of fractions, but we're going to deal with it by really kind of just dealing with the numerator and then just dealing with the denominator separately and then doing our division thing that we learned in the last lesson. So I'm going to write out what steps I would do. Now there are other ways to do this problem. There are other ways, but this is what I do every time because I'm boring. I want to do the same thing every time. I don't want to learn a new strategy for the different ways that it looks. So if I've got a complex fraction, which means fractions over fractions, this is what I do every time. Number 1, I get a common denominator for the top and the bottom, for the numerator and denominator, for, I'll just say top and bottom. Then add. I add them together. Step 2. All right, I rewrite it as a multiplication problem. Okay, then step 3, I simplify. Okay, I do that every single time I have a complex fraction. And I mean, I can't even count the number of times that I've had to do it and the number of different courses. We do this in Algebra 2, we do it in Pre-Cal, we do it in Calculus. I mean, we always have to fix complex fractions. That's a thing. So let's look at our numerator. I see that I have x and a 2x, so that means this fraction needs 2 over 2. Okay, good. That's going to fix that one. Look at the denominator. I've got a 3x, the denominators, 3x and a 4x. Let's see, they both have x's. That's good. But I have a 3 and a 4, so their common denominator would be 12. So multiply this by 4 over 4 and this by 3 over 3. Okay, so let's take care of all that multiplying first. So let's work on the top fraction. 2 times 1 is 2. 2 times x is 2x plus 3 over 2x. Okay. Then we've got 4 times 1 is 4. 4 times 3 is 12x plus 3 times 3 is 9. And 4x times 3 is 12x. Okay, great. Got my common denominator. So let's add. So we got the common denominator for top and bottom. Now we're going to add. So remember, we add across the numerators. So 2 plus 3 is 5 over 2x over 4 plus 9 is what? 13 over 12x. Now when we have complex fractions and we get it like this, we need to make sure we really pay attention to what the main fraction bar is, because we can get really confused about this. So the main fraction bar is still this one right here. Okay, that's the main fraction bar. So step 2, we're going to rewrite it as a multiplication problem. So I have 5 over 2x times, and I flip that back one upside down, right? So it'd be 12x over 13. Okay, good. It's looking good. So now I'm looking for common factors to cancel out. I've got, I think you can see I've got this x over x. We know the same thing over itself is 1, so that's going to go away. That's gone, that's gone. Then we have numbers. Let's see, we've got a 2, and this is what, 2 times 6, right? And so this one has a common factor of a 2 and a 2, so those are gone. Let's see, any other common factors? No, it doesn't look like it. So I've got left over, I've got 5 times 6, which will give me 30. And then the 2 and the x, those are gone, so that will give me 13. 30 over 13, which can't be simplified. 13 is a prime number. And that completes our lesson.